Hello all, I am Siddharth Kaul and I welcome you to Edupedia World. In this video, we are going to revisit some of the programming concepts in MATLAB. So I am going to start with control flow. The if and else statements. If and else conditional statements allows us to select at runtime which block of code to execute. It can include alternative choices like else if or else as shown in the example. The examples demonstrate a very simple use of if-else statements. A random number a is taken and its condition is checked. If the value of a is less than 30, then we will display small. If value of a is less than 80, we will display medium, or else we will display large. In cases where we want to test for equality against a set of known values, we use a switch statement. Here in this example, we know there are fixed days in a week. Hence, we are comparing the string against the known days of the week and making decision accordingly. You can clearly see that we are having separate cases for each day of the week. For Monday, Tuesday, Wednesday, Thursday and Friday. And accordingly, we have displayed like start of the week for Monday, day 2 for Tuesday, day 3 for Wednesday, day 4 for Thursday, and last day of work week for Friday. And by default condition, we have written as weekend. So for both if and switch statements, MATLAB executes the code corresponding to the first true condition and then exits the code block. Each conditional statement in MATLAB requires an AND keyword. Other than that, the code styles are much similar to that of other programming languages such as Python. MATLAB obviously provides control over program loops. For loops repeats a group of statements a fixed predetermined number of times. We use semicolon in inner statement to suppress the repeated printing. This is similar to most other for loops used in other languages. Somewhat similar to for, we have a while loop that repeats a group of statements indefinite times under the control of a logical condition. So until a condition is true, the statements will keep on repeating. It is as simple as that. It is important to understand how relational operators and conditional statements work with arrays and matrices. When we consider two matrices A and B and use if operator as if A equal to B, the statements still hold valid. The difference is it does not test whether they are equal, it tests where they are equal. The result is another matrix of 0 and 1 showing element by element equality. In fact, if A and B are not of the same size, then A equal to B is an error. For example, we have taken a matrix A for a magic matrix of dimension 4. We are taking another matrix B that is equal to matrix A. Now we are replacing the first element of matrix B with 0. Now we are executing an equal operator, that is A equal to B. As you can see in answer, we get all other elements as 1 except the first element, that is 0. So this is how a matrix behaves when it is put with an equality operator. So what is the proper way to check equality between two variables in MATLAB? So the proper way to check for equality is to use isEqual function. IsEqual is the recommended function to use to check equality between any two variables in MATLAB, whether it be scalar or matrices. IsEqual function returns a scalar logical value 1 or 0. 1 represents true and 0 representing the false. The continue statement. The continue statement passes the control to the next iteration of the for loop or the while loop in which it appears, skipping any remaining statements in the body of the loop. The same holds true for continue statements in nested loop, that is, execution continues at the beginning of the loop in which the continue statement was encountered. For example, here we have a program that counts the number of lines in the file magic.m. So we open the file as read only. We take a while loop that goes till the end of the file. We get a line. If the line is empty, we continue and we do not increment the count. So whenever an empty line is faced, the count is equal to count plus 1 statement never executes. So whenever the if condition is true, the count equal to count plus 1 never executes. This is how a continue statement works. The break statement. The break statement lets you exit early from a for loop or a while loop. In nested loops, the break exits from the innermost loop only. So here in this example, we have a break statement inside the while loop inside an if condition. So whenever this break encounters, the whole loop is broken and it comes out of the loop. The return statements. The return terminates the current sequence of commands and returns the control to the invoking function or to the keyboard. Return is also used to terminate keyboard mode. A called function normally transfers the control to the function that invoked it when it reaches the end of the function. You can insert a return statement within the called function to force an early termination and to transfer control to the invoking function. One way to make your MATLAB programs run faster is to use vector algorithms. Vectorization is one of the most powerful features of MATLAB. As MATLAB is completely based on matrices, vector algorithms makes much more sense. Other programming languages uses for loops, do loops or do while loops for performing certain operations or performing certain algorithms. Whereas if algorithms can be vectorized, MATLAB uses direct vector or matrix operation. In the example, I am creating a table of algorithms. On the left, a more traditional way is shown using a for loop, and on the right, the vector way is shown. So as you can see, how simple the vector makes the coding. Scripts and functions. There are two kinds of program files. Scripts, which do not accept input arguments or return output arguments. They only operate on the data in the workspace. And functions, which can accept input arguments and return output arguments, and their internal variables are local to the functions. Scripts. Here are some key points for scripts in MATLAB. When a script is invoked, MATLAB simply executes the command found in the file. Scripts can operate on existing data in the workspace, or they can create a new data on which to operate. Although scripts do not return any output arguments, any variables that they create remain inside the workspace. These variables can be used later for doing subsequent computation. In addition, scripts can also produce graphical output using functions like plot. Functions. Here are some key points about functions in MATLAB. Functions in MATLAB accept input arguments and return output arguments. It can input multiple arguments, and it can also output multiple arguments. The name of function and the name of file should be of the same name. Functions operate on variables that are inside their own workspace. This workspace is separate from the workspace that we access from MATLAB command prompt. So all the variables that are created in the function are local to the function itself. Here is an example for a function. The first line of a function starts with the keyword function. It gives the function name and order of the arguments. In this case, there are up to 2 input arguments and 1 output argument. The next several lines highlighted in green are comment lines. This provide help text. These lines are printed when we type help and our function name, that is rank. The first line of the help text is a header line, which MATLAB displays when you use for look for command or request help on a folder. The rest of the file is executable MATLAB code. The variable s introduced in the body of function as well as the variables of the first line r, a and tol are all local to the function. They are separate from any variables in the MATLAB workspace. Point to remember, all these variables are local to the function itself. You cannot access these variables outside the function. This concludes our video on revisiting programming concepts. In the next, we will look into some of the few examples using programming in MATLAB. Until then, please subscribe and thanks for watching.